Hey guys, welcome back. In this lecture, we are going to talk about how we can identify if a problem can be solved using graphs. The simplest thing to do to identify graph problems is to focus on why we should use graphs. When there are paths or relationships between the entities, there is going to be a problem well demonstrated and solved using graphs. Basically, the main theme behind graph problems is that there will be the need of taking entities, considering certain relation among those entities. For example, if the problem is asking for finding shortest distance from a place to another place, then the nodes will be all the places and there will be some distance between them which will play the role of relation here. So the edges will be the distance between respective places. Or when you have to cover all the cities in minimum cost, then the vertices will be cities and the edge will be the cost between two cities. When there is a network and you have to maximize the flow across that network. For example, if it's a fluid network, then the vertices will be the fluid junctions and the edges will be the pipe capacities. If it's a rail network, the vertices can be railway stations and the edges can be the length of railway line between the pair of vertices or stations. And if it's a social network where there are a lot of interconnected users, then the vertices can be the users and the edges can be their relation. When you have to find whether a place is reachable from all the other places, or when you have to find whether all places or objects are reachable from each other. Anything that you can think of that either considers some kind of path or relation, chances are very high that it's a graph problem. If you are able to understand the intuition behind the problem and really can figure out such a graph representation of your problem. But remember, you have many data structures in menu while deciding for right data structure. You have lists for linear relations, you have other data structures, even you have trees for hierarchical relations. Then what makes graphs a right choice? It is the flexibility of graph data structure to allow complex relationships. With lists, you can only have linear data. In tree, you can have hierarchical data, but again, all the nodes have to be connected and there should not be any cycle present in there. Tree also is a graph, but it's a connected graph with no cycles. So again, there are certain restrictions. Whereas graphs can model any kind of data. It allows multiple edges and multiple paths connecting the vertices. There can be disconnected vertices. There can be directions. It allows loops. Graphs can be undirected. So it's the flexibility to model complex relationships among the entities. So we'll definitely be needing a graph when data is not just hierarchical, but there are complex relationships present in data. So this is kind of my way of identifying graph problems, but there can be things you're gonna get with practice. It gets better with practice.